This is the entire agenda for today. I just cribbed this off the website. You arrived at 8 and had coffee and snacks, and then you listened to Moans talk about the cloud. C-L-O-U-D. Really strange way to spell time sharing. And for those who know my history, I won't say the letters DTSS. And then I'm speaking from now for about 50 minutes, and then Carrie Osborne will end. And this is all up on the website. You should be able to find all of this. Okay, the thing I am talking about is minimizing the concurrency footprint of transactions. And this is who I am. That's all boring. I'm a dinosaur. I've been around forever. I'm a United States Senator candidate in the primary twice in New Hampshire. The first time in 1992, when I'd recently been mayor of a small town in New Hampshire, Lebanon, New Hampshire. And I was actually briefly favored to win until the last day of filing, when the sitting governor and scion of an historic political family in New Hampshire, Judd Gregg, entered the race and crushed me. In frustration at lack of policy proposals in 2014, I ran again, and because I wouldn't make any media buys, I was denied access to the televised debate. At the in-person debates at several colleges, my policies were roundly chosen as the workable future for the country. But this is not a political talk, but I needed to explain the Oak Table World come on tweet about me being a senatorial candidate. That actually ended in defeat in 2014, and unless drafted by the party, I probably would not run again. Okay, so let's talk some technology. Oh, one more aside. There's so many good sessions here at Oak Table World 15 that you probably can't see all the sessions here and all the other sessions you want to see at some other conference that's running in the neighborhood. So come to collaborate, mark it on your calendars, April 10th to 14th, 2016. It's in Las Vegas. The call for papers is currently open. If you were smart enough to find your way here, you probably can write a valuable abstract and give a great presentation and collaborate. I think it's open only until November 6th, so get busy. Okay, I told you a bit about me, made a pitch for the IAG, and now I'm going to frame what the heck I'm talking about. And then I'm going to tell you to instrument your code, study ways to submit a trivial transaction in tedious but important detail. And yes, I am indeed reading my slides. These are essentially my notes, so don't become enamored of the PowerPoint. These are just, I don't have slides other than some data and the words I'm going to say. Okay, moving on, we'll do some considerations from the trivial case study about minimizing the concurrency footprint, which you'll by then know what I mean by that. And then we'll move on and do a brief study of a more complex transaction. I will remind you to establish an order of updates amongst your tables and rows if necessary, or if that can't be done, have sentinels to protect transactions from deadlocking with each other. If a business rule forces you to update some things in differing orders, you may need to prevent them from simultaneously being executed, because Oracle will perfectly well wind back the deadlock in about 3 seconds. So if you are worried about concurrency and high levels of transaction rates, you never want to let your failure to avoid application deadlocks fall to Oracle. They are a deep safety net, and they will save you and unwind your deadlock and prevent your entire database from hanging up. However, if your partial transaction is, they only wind back the root cause of the deadlock from a multi-step transaction, and so your partial transaction will be sitting out there uncommitted, and unless you take care of it, it will be holding locks and will destroy concurrency. And then we'll go on beyond Zebra. I'm assuming I'll get to that, about some dirty tricks that you should only do after you've implemented and discover that you need to do more than what just falls out of the database working for you. Okay, so concurrency footprint. My definition is the duration of possibly blocking something else. And I want you to learn how to, and to avoid unneeded increases of the concurrency footprint for your transactions. I want you to design transactions with room for footprint reduction. So out of the box, you might just be lazy and build the thing as if Oracle's normal mechanisms, and just do the transaction steps and everything will work, and as the transactions are processed, enough of them will clear and you won't butt heads with each other, and you'll just get normal concurrency waits once in a while, but things won't unravel and things will go as fast as you need them to. So that allows you to minimize the initial complexity. I want you to design with room and hooks in your code for you to do special things, which I'll get to what some of the special things might be, and you can come up with more ad nauseum if the need arises. So you minimize the extra work unless it's needed, but the plan is in place. I want you to build things in terms of a harness where you can reduce the concurrency footprint, and sometimes that's more work. It's not synonymous with making the total work done to do an update as small as possible. Sometimes you will do extra work in order to make the duration when the transaction is in flight shorter. Okay, and you will care if your transactions, if you're a startup and you experience organic growth and all of a sudden you're getting tens of thousands of transactions per second where you really only planned for hundreds. And you will be able to make adjustments if you build this way. And as we enter time sharing, CLOUD, there will be an increasing temptation to do things on a remote client and construct code there and control code there to minimize your expense in the time sharing and offload to people's dumb CPUs that they're connected to the network with. And it becomes particularly important to, even if you do that, to engineer your transaction submission so that nothing can get stranded between the remote client and the time-sharing bureau, the cloud. Okay. So, in this guy's concurrency footprint is mostly about small transactions. This is not where you have an opportunity to depart from slow by slow, row by row is slow by slow. This is all you have is a few bits. The metaphor I'm going to use in the example is a sales metaphor where you're reducing, you need to see that there's a piece of the transaction there in an inventory of what somebody wants to buy, and you're going to reserve that item for them and ship it to them, their shipping address, and charge them money. And these aren't massive transactions, so there's no play there to turn these little row by row things into set transactions. which is, of course, always what we want to do in batch transactions to get them over with much more quickly. You'll find that line turnaround is a significant fraction of the time, even if the client is on the same laptop as the database. Okay, and is there anyone in the room that doesn't know what a logical unit of work is? Has never heard that term before? Oh, cool. All right. And so that's good. Now, next thing I can tell you, instrument your code. All of it. Is Carrie here? Anyway, that's a direct quote from my friend Carrie Millsap. Trace your code, all of it. There's a blog he wrote, he's on Archbeat, an Oracle blog, and it's a good watch, and it's only 2 minutes. PL SQL is excellent for instrumentation. You can, among other places, you can learn all about that at Method R. And there's a paper still up there by the late, great Karen Morton. And it's getting dated a little bit, but it's still precisely correct in every detail as far as I read it. So I'm not going to talk about instrumenting your code other than telling you to do it. And here's at least one resource that will give you a very good way to instrument all your code. Okay. Now, ever since some guy at Sun invented this language that is named after a cup of coffee, there has crept a disease across the developer world of building applets on little devices because the compiler for that cup of coffee is so portable and small and wonderful. And what's happened over time is people have written whole code suites and auto-generating queries and things like that, and entirely on the laptop or on a phone, and then they submit them across the network in pieces, and incurring great risks of injecting things into your database. And they will tell you, well, we really could not do that responsively to our customers and have the flexibility of the code if we don't do it in a cup of coffee. So I'm here to tell you that the complete set of languages required to do all possible things, including Lisp, Fortran, PL1, and Snowball, Simula, Smalltalk, were all completed before I graduated from college, and I am old. So logic can, and then PL SQL came along, and that's in the database server, and you can do all the logic you need to do right there. And if you need to do database transactions, that's that, or if it's really complicated, you can write an OCI or Pro-C program to do that so that you can control the transactions on the server and not get stranded across the time-sharing connection to the client, from the client to the server. You can still compute and make all your choices and have pretty fancy screens, and all of that can be done on a mobile device or the remote client PC or even a 3270 terminal if you can find one that still works. But this allows you to ship tokens and small communications, minimize the size of communications across the network, even if you have a super network. Eventually, at some point, there's going to be a hiccup in your network and extended latency. And if you've stranded the construction of a transaction that's already in flight, and the server doesn't have the rest of it yet, and it's in flight, you're going to hold all those locks until the last bits of that transaction arrive, or you decide to kill it from the server. So don't do that. Seriously. even if you have a super network. Oh, cool. Wow, we're being live tweeted. Cool. A cup of coffee is Java. All right. So, and by the way, I'm something of a dinosaur, and when I worked at Burlington Coat, we were early adopters of Unix. And so, because we were converting peoples from mainframe systems and leading kind of the charge, Unix International made the IT development staff of Burlington Coat the Unix International Award winner, and I think it was 1993. So we got to have dinner and this Unix International dinner, and Scott McNeely was there, and Dennis Ritchie was there, and it was all fun. And so I have a baseball cap that was the handout at the release of this Java, and I still don't like it. But I still have the hat. I'm going to sell that for a lot of money someday. Okay. So I'm going to go through some ways to submit a trivial transaction. First of all, and these are trivial, but you could do something very complex, and you could submit these from a Java client and have something huge and complex. This is just a single transaction step of what could be a multi-step logical unit of work. So I'm going to just ship this in, update the inventory, and then I'm going to commit it as if it weren't a even in the single step from the client. Can you read in there? The important part is this is trace code. I forget at what level, doesn't matter. But if you read through there, you can see, okay, so he submitted from SQL Plus with substitution variables, so that got turned into literals, and there's that update in yellow. And then you can see that it gets parsed and blah, 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 blah. And then it notifies back to the client, this happens to be SQL Plus, it says, hey, yeah, I did that. And then the client comes back and says, and then it waits again and says, okay, now I'm waiting for him to come back, and now I ship in the commit. Now that was from my laptop to my database here on the machine, so that didn't take very long. But that's even single transaction and then sending commit, you wait. So we can do a little better than that. So we could build and send in a PL SQL block from a client. Okay, and then so that arrives, and this is what now appears in the trace. We get this block, it hasn't been parsed before, so we parse it, and we bind the values in. And once again, SQL Plus turns these things into literals unless you're, I'm sorry, I did use bind variables there. So these are bind variables in this example. And so it does the bind, and there's the parsing of the actual update statement after it's got the initial receipt of the bind variables value set. And then you see the binds are worked into the parsed plan, and then finally it gets executed, and then the commit takes place. And you'll notice there is no SQLnet wait pair. And the repeats won't have a miss on the cache, so they'll do even cheaper parsing than this one was, unless, of course, they age out. And so here you see just that trivial change. Even if you're still submitting it from your remote client, if you at least bundle up all the bits of your transaction and ship them all in before the thing starts, then you can't get hung across the network. Okay? But don't stop. We still had to ship all the code, and we could do much better with a package procedure stored in the database. And that means also that you can instrument, you can add the instrumenting code that I told you to put in, which I didn't put in any of my examples because I want all of them small enough to view on the screen, which is the only excuse for having PL SQL packages that don't have full instrumentation in them, is if you're using them in a demo that you want people to be able to read on the screen. Okay. So you can instrument them without adding code to ship. And you can just call them by name, and they can have little tokenized names if bandwidth is an issue. Then you can keep them in the shared pool. You don't have to. Oracle sorts that all out for you. But if you've got a mixed load of transactions, you don't want something used semi-frequently to age out. Because if it ages out, then you've got to get it back in. And if that happens, some package is executed in the middle of your transaction that it has to go find again, there's extra footprint. Was that a question, or are you waving at someone? Okay, that's fine. All right. So keep things that are on busy transaction systems. Keep them in your shared pool. The important bits that you want to minimize the concurrency pool or footprint for. And you can preload big things at slack time. People know what I mean by, does anyone not know what I mean by slack time? Okay, all right. So we've evolved into a world of 24/7 operations, and you never shut down or anything. But there are still ebbs and flows in your workload. And when you have to, for some reason, shut down a database and then start it back up, usually you can take a little bit of slack time before the flood of transactions come in after you open yourself out to the world. So I call that slack load. In other words, your machine has extra capacity and headroom. Load things up then, so and warm them up and keep them in cache if they're medium big. Things you don't want to be direct reading all the time. Little bells and whistles that get referenced into. Anything you can keep in your buffer cache that's small to medium big that you can avoid using even the column store or going to direct read or adaptive reads or anything like that. It's always faster if it's in main memory when you're doing small numbers of rows. I want to be careful to say that, because if you're doing great big pant load reads of direct read into the PGA, that's faster than going through the buffer cache. But remember, we're doing little wiener transactions here, and probably only some crazy thing like somebody's address or the friendly name of an inventory item or something like that is what you're going to be looking up here. So these are little bitty things that you're going to want to yank one at a time out of the buffer cache. And then that's always faster to do it that way. If somebody prove me wrong, please. Okay. So, and you can manage keeping stuff in cache if you tend to have problems with it aging out, like you have slack time in you have ebbs and flows in your cycle, like Sunday morning at 5 a.m., hours and hours go by with none of your normal interactive load heavy transactions, and maybe some batch process is executed and it trashes your buffer cache and throws out all the things you want in there. That's okay. You can set up little jobs to reread things and say, hey, is this stuff in cache? No, it's not. Okay, read it back into cache. That's a dummy heartbeat call, or anyway, so you can manage all those things. But remember to be lazy about this. Okay, don't build and engineer all this stuff until you need to for reasons of concurrency. Okay, but remember that you can. Okay, and so if you start finding, wow, I need to sweat, the last few milliseconds or microseconds off the time this logical unit of work is in flight, then you can do all these things. And you can do it best, in my opinion, on the server and with a stored PL SQL routine. Brendan Llewellyn kind of likes me because I keep saying this a lot. You can make an argument for C programs still for certain complex transactions. So now I showed you a couple just shipped from the things, and here's still that same little tiny transaction. Here is a stored procedure. And I'm going to show 3 examples of submitting this. And the first one comes in, and this is with the with the substitution variables. So they come in as literals, and it gets parsed, and look at that, it takes a long time, 1522, and then when the update, so that's parsing the blocks sent in, or the exec call, and parsing that, and then we're going to execute it, and that parses a little quicker. And then down below we're going to do the exec. And see, all of this happens, none of the code's shipped, just this little tiny execute is shipped. Very little transmitted across the network, and it all arrives, and then it's all executed, and then you reach the commit, and there's nary a wait in sight that you could otherwise avoid. Okay, now we're going to do submitting the procedure is one block with the bind variables within the begin. And you can see that comes in, and you see the little bit extra that gets shipped in, and then it runs all the way through and reaches the commit with nary a wait in sight. And now the other way you can do it is you can break up the binding of the variables from the submission of the exec. And that's useful in two ways, and I'll show you some. I'll show you here. Now, so first bit that's going to get shoved in is that just the bind variable assignments in the begin block. And it goes in and it's going to parse that, and you will get a line turnaround. Okay? So you might think, oh wait, no, I don't want to do that. But remember, the transaction hasn't started yet. All we've done is assign some bind variables. There's no locks. There's a little bit of memory. It does need a parse lock to make the assignment, but it always needs to do that. And it comes and goes, and they're just in your session that you now have these bind variables assigned. And so this big yellow, but notice these are waits before the transaction starts, and then the rest of the bit comes in, and there is the execute that sale. And then you can see it goes through, and I do this twice because I want you to know that this was a fresh parse, so you see that elapsed of 303 there up in the top purple line. And then we get down below, and then it's doing the individual bind parsing of the variables for the SQL statement within that bind variable, and then that all executes and goes on down through the commit with none of these potentially long network waits. And now we're going to do another one. Now remember, this is the same session. We submitted another one. Only instead of 42, we remembered that the universe is base 13, so we've got a 54 in there now. And if you don't get that joke, that's okay. And then, once again, no transactions in flight. We get these network waits then for the rest of the bit. But you'll see now, instead of having different bind variables in the block that arrives, the block that arrives is just the execute with the bind variable references. Well, it's seen that before. Okay? It's seen that before, and so instead of 300 something to parse it, you see that E68 on the top purple line? Okay? Because all it had to do was say, oh, I've seen you before. You're exactly the same. And you can't do that when you include, even with bind variables, the bind variable assignment in the block you ship in. Okay? So that's why it's useful to say, send up all, even if you're doing it from a remote client, send up all my value binds, and then call the routine just with the symbolics, and then it'll find it and parse it quicker. And then from there on, you notice that the times of all the things happen, and that the underlying SQL statement inside the procedure already has a SQL ID handle because it's already there. So none of this parsing now takes each time. Now imagine that this wasn't just a single statement, but a multi-statement logical unit of work. Maybe you got half a dozen, maybe you got a dozen statements to effectively transact. You got to take from the bank account of the guy. You got to find out his shipping address, and you got to do a bunch more updates than just a single one. Well, if those were all parsed before, and even if the first time you have to parse them, I guarantee you're ramping up on your concurrency. Hasn't happened yet when you get the first one. You're not at your ceiling rates. But if you do this and you segregate the value, the particular value submission blocks from the call blocks, you'll find that all of those bits are pre-parsed, sitting around in the shared pool, ready for you to run. It's a wonderful thing. And it recognizes them. Yes?
This is where you assign your values to the bind variables in a block.
Right.
What if you're doing the bind variables in, say, your coding time?
What I would say is, in that case, you would want your program to reside on the server and still send the values and choices into that, and then have that program swallow them on the server, so it's never waiting to get them across the network. So I don't think you should submit bits of a transaction across the network. However, what you can do, if you really need to build it on the client, is keep the execute and commit for all those bits till the end. So you do the call and it says, you know, submit this call prepared, prepare this one, prepare this one, prepare this one, prepare this one, until you get all of them, and then go exec, 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 and use the whatever number of independent cursors you need to use to have them all ready to go, and then fire the thing that says execute this open cursor, execute this open cursor, boom, 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 and commit. So that's how you handle that if you're using a good programming language where you can do that. As opposed to I'm just using a SQL Plus client in this case for this demo. Which is somewhat better than a cup of coffee, but still has its challenges across the network. Okay, so thank you for the question. All right, so I'm doing okay on time. So we'll review what we talked about. If you exec with substitution variables, it reparses for any change. Cursor sharing is no help. I didn't show the demos of that, but I ran all the flavors of that. If anybody can show me a way of cursor sharing that will allow this to not reparse when you hand in new bind variables to be bound, I'll be greatly surprised. That's not really a cursor, okay? It doesn't open a cursor, but it does require a library latch to do the parse. I don't know exactly, Oracle has not given me their source code since 1987, so I don't know exactly how they do it anymore, and that was Oracle 5. So I don't know exactly how they do this currently, and even Oracle 6, we didn't have a shared pool. So I may have seen some of that code, but Larry doesn't know. Okay, so a single block reparses even with bind variables, but if you do it as 2 block pieces, then you reparse just the values submission, which is not part of the transaction time. It's not part of your concurrency footprint. And it just binds, and then you execute the call. And I did remember to note the smaller parse time, because now it completely recognizes that block you sent up that's all just symbolic. They're not different in any way. It's just the variable names. And then you can come up with better models, as this gentleman mentioned, if you're using things like OCI bind and stuff like that. You can engineer this differently and do some things with a late arriving but still well-formed language called C. Yeah. I rue the death of PL1, but it happened. Okay. So now we're going to move on to slightly more complex. This isn't still really real complexity that you'd see implemented, but it's approximate. So we're going to sell and ship some amount of something to I don't know where that P came from. That's to someone. Still pretty simple, lots of opportunities to speed up comparing to client ship code and stored procedure. Okay, so here's the logical unit of work with a SQL plus bind coming in, and you'll notice you ship it all in at once, and then it's going to be sitting around waiting for the commit. And oh, I'm sorry, no, this is the OK one. I'm sorry, I screwed up in my comment. This is once again where there's a wait, but it's not within your concurrency footprint. Okay, so then you go and you got lots more bind variables going on here, but still it's all within the execute. And so you do have to bind the variables in, but they're already up on the server and they don't disrupt the parsing. So then this one is going to take place, and it's going to do the inventory update, and then it's going to subtract adjust the on hand, and then it's going to get someone's shipping address and insert that to I sold something, and then right, I'm sorry. Forgot to say what I was doing. I added some of that extra complexity I told you not to do initially. So first, before I proceeded, I put in here, at the top of, yeah, I'm going in the wrong direction. Okay, go to slide. Right, okay, so this arrived, and the first thing we're going to do is see, before we start updating things, we're going to see if we got enough on hand. Okay, before I just did the update. But here we don't want to go below 0, so we're going to see, do we have enough available to sell? And this is going to cache my block with that individual item in there in the quantity. Hooray, hooray. And so then I'm going to, then I see that I had enough there to satisfy the sale before I started the transaction. Wasn't part of the footprint. But now I'm going to assign the bind. Now I'm going to assign the bind variables after I know it's likely I'm going to have enough. But I'm still not in my footprint yet. Now I'm in my footprint, and I'm going to call this cell 1. And in the cell 1, I'm going to once again update, and in the course of that, I'm going to check that I didn't drop below 0. Here we go. This is the right place. I'm going to check that I didn't actually drop below 0. Let's see what time it is. Just a second. Okay, I still have time. And before I commit the thing, I'm going to say, gee, I didn't drive inventory below 0. Okay, but that's all cached, and I'm actually doing it by row ID at this point. Since I had to check the inventory before I started the transaction anyway, I switched to row ID. So I didn't do that laziness. You could, right, and only say after the fact, oh, if I commit this, it'll make the inventory drop below 0, so let's just roll the whole thing back. And that's the lazy way that would be good, to start out building it, to let Oracle do all that busy work for you. And this is demonstration of things you might do to reduce the concurrency footprint. And these are just examples of techniques, all right? Check if I have stuff before I try to update it. And maybe I would have an exception if the resulting inventory didn't drive or drove me below 0. Okay, so that's what this example shows. And then, so I had enough, and now I had enough, and I didn't drop out and roll back. And so now I'm going to ship it to someone, and I didn't, and I may have pre-selected this. The next step, if that wasn't fast enough, I might have pre-selected the ship to address and gotten the information all queued up before I started the transaction. But concurrency wasn't that bad yet, so I didn't. So I remained a little bit lazy. So there's still room for improvement. Okay, and then at the end, I'm going to recheck the quantity available, again using the row ID, and finally do the transaction as quickly as we can, and give it a shipping ID. And oh, this is where I'm checking that I didn't run out of the amount. It's a little hard to read because of the detail tracing. But that's what's going on here, is I'm making sure I didn't go below 0. And then we do all the binds, and this is where I haven't really started the transaction until now. Okay, and so there we go, and that's insert starts, and there's the transaction and the decrement. So I'm going to review. We use the stored procedure to ship a minimum amount of code. We could encode the names of the coded modules. In other words, when you develop stuff, you might want to develop it with a friendly name, and then before you shove it out in production, you might have a part of your code control system could be regenerating the production stored packages to symbolic names, starting with like A1. And the shortest possible names for the most frequently called. And that does a couple of things for security too. So people have no freaking idea what it is you're doing. Hey, somebody sniffed an A1 with these arguments flying across the network. And it adds a little bit of an extra step into what's going on across the network. Now, once again, that's a lot of extra over-engineering if you don't need to do that. But it's a possibility. You want to design that you could do these things at need. So you want to design things very basically and transparently so someone can trivially read the code and understand what it's doing, and then think about and plan where you put the hooks if you reach a growth crunch where you need to severely restrict the concurrency footprint. Okay. So notice we cleaned, so reviewing, we shipped a minimum of code, we fetched clean blocks and values. Remember, because these might be highly updated, and you might have some delayed block cleanout to execute or something like that, and we want to have fresh good blocks to come in. And then we bail out of the actual transaction if there isn't if we know in advance we can't complete it and satisfy it. And then once the transaction starts, there's no fat. And the package was warmed up in the shared pool, so you didn't see elapsed time parsing the bits. It was just found the SQL handle ID that assigned it to this thing. Okay? So there is a trade-off between the size and the possible transaction time load. Okay? Without all these bells and whistles, if you're not hitting up against concurrency issues, the simplest way to do the transaction, Oracle will do it more quickly. But by doing the extra block fetches and things like that, I don't have to wait for them to occur. I pay for those in CPU, but I don't pay for those in elapsed time during the concurrency footprint. Okay, so I think I just said all of this. So this was a little bit beyond the lazy rule for the demo, because I want to show you a few little things about doing that. Now on Beyond Zebra, things you don't do in the code, but which you could do at the database level. And this is with regard to the hot block problem. So all of a sudden, you weren't suspecting, but flat bottle openers with green print that can also lift the pop top off a soda can become very popular. And now you're selling many, many, many of those in small lots. And the block in the inventory of that is getting hit by thousands of updaters. And so now even though you're prefetching it and checking the inventory, people are going to start waiting on this thing to get their turn at the block on that row. So if that were to happen, what you would want to do, and you could do dynamically at the database layer, is hermitize the popular values. Does anyone need a definition of hermitize? I made this word up. Okay. A hermit lives alone in a hut. A hermitized row lives alone in a block. Okay? So there are a few ways that you can hermitize popular values. And one is to add an artificial extra value. I hit on this one literally, building transaction systems that did involve inventory and sales, because we had physical warehouses. And we noted that, and we had a real concurrency issue even within the physical warehouses. So what we did was we dithered this out. We actually partitioned by warehouse, and we added fictitious virtual warehouses that each mapped to one physical location, but we just spread out the virtual warehouses into different blocks, so that then these highly popular items, you could fan them out into individual blocks, but it required partitioning. Now, if you don't have partitioning and you need to do a little more simple model, what you do is delete, add dummy inventory items to your inventory table until you're on a fresh new block. Add in the real one you need. Add in enough more dummy, never to be used inventory rows to fill up the rest of that block, and voila, you have hermitized your row. Now, would you ever do this out of the box without running into a concurrency problem? Not unless you knew, like it was going to be, say, a Burning Man ticket that you were selling, and you knew that hey, later this week we're going to sell 50,000 tickets to Burning Man in the space of 5 minutes or 5 seconds when they go on sale. That's a true thing that happened to PayPal a number of years ago. They handle it fine, just fine now. It's by other means than this, so you can use dirty tricks at the data layer to avoid hot block problems, and then when you combine that with minimizing your transaction footprint, you end up with something that's running as fast as it can without scaling problems that you could have avoided by a little extra engineering. And these are just, of course, examples for the inventory sales simplified model. Whatever transactions you have out there that you're considering building as logical units of work, think about them at the design step. Think about, what would I do if this became a highly competitive race condition transaction? And so you build the hooks in at that time and think about the places. You might even put some comments in the code if it seems likely. You know, I could do this here. But don't do it yet unless you need to. If you really know you're going to need to, go ahead. But you want to keep the actual code as simple, as straightforward as possible until you need to do this. But you want to design it in. Okay, so you've just seen minimizing the concurrency footprint of transactions. I have 4 minutes if I read my time, or no, I'm 1 minute over. I'm 1 minute over, so I should stop now. This is the rest of the talks that are coming up, and I do have one quick bonus. This is Henry Bishop Dansby, my grandson. Cutest kid on God's green earth. I will argue the point. And these are my friends. Oh, these are my friends from my daughter's wedding reception a couple of years ago in the fall. And if you can't see who they are, that's Jack Black and Zoe Deschanel and John Ritter's son, Jason. And they literally jumped into the pool at the wedding reception. And soon everyone was into the pool. And I want to make a plug for the show. My son-in-law is director of Drunk History, which is has a good relationship with the Oak Table. And since we're always ready for a real Oracle symposium, and he also is the director and one of the producers of Another Period, which you'll find on Comedy Central. So it's pretty heady stuff getting to meet these celebrities in person, and it turns out celebrities are just folks like us, and they jump in the pool and have a ball. So thanks for staying around and not clearing the room for my presentation, and whoever's up next, I'm going to get out of your way directly. Oh, it's Carrie Osborne, right? Oh.